Okay, in 5.5, we're going to split this over 2 lessons. We're going to skip lesson 4, just so you know, it's not an error, it's just we're not going to do it. So measures of central tendency. This is how we can kind of get a baseline measure of different sets of data. You're familiar with the first half of this, I'm sure. The mean is just the average. That's another way to say the average, the mean. And this is a fancy M. You might see it written as a fancy M. I want you to be prepared for when you see it. If you see fancy M, that means mean. The median is the middle. Just like in the highway, if you drive on the highway, the middle of the highway, that grassy part that you shouldn't drive over, some of you are entering driver's training, I hope that they covered this, you should not go over the median to go on into oncoming traffic. Okay, that is just the middle number. The mode is the most. It's the thing you see the most. So let's find the mean, median, and mode for these sets of values. Okay. I always start with reordering from least to greatest. So let's see, smallest number in this set, 35, and then 46. I got 51 twice, 53. Probably could have done this before I started recording, but hey, we do it live. I got 2 58s and 59, 60. Okay, that is useful because now I can find the middle value. I can just count inwards. Which one's in the middle? 53. And which set appears the most? Well, I had 2 51s and I had 2 58s. It's okay if you have 2 modes. It's okay. It's simply just what shows up the most. If 2 things tie, well then they tie. All right, now the mean. We need to add together all of this. We need to add it all together. And I did that before, and it was 471. If I add all this together, I get that. And now we just need to divide it by how many data we have in the first place. Like 1, 2, 3, 4, 5, 6, 7, 8, 9. I got 9. And I figure out that the mean of this value is 52.333333. So we can write 52.3 repeating. Okay. I'm going to do the exact same thing down here for example 2. Smallest to greatest. Where are we at? So the smallest number here I think is a 7. And then I see a 10 and an 11. 2 15s. Got a 19. 21. 3 24s. 27 and then 31. Okay. Now let's find the middle value. I messed up. Okay, so the middle value actually is between those two. So how I figure out what number is exactly between? Well, it's actually easy in this case, but here's how you would do it if it was not easy. You would just add them together and then cut them in half. The middle value is 20. Even though it's not represented in that data set, it's still our middle value. The thing that showed up the most, well, I had 3 24s. And now if I'm gonna sum all of this together, add up all of those values, I'm gonna get 228. And there's 12 total numbers. So it's gonna begin with a 1, I'm gonna guess it's, I don't know, 11 something. Oh, it's 19. Where's that go? Wow. 1, 10, yeah, okay, 19. Here There we go. It's a nice even number. I was not expecting that. All right, mean, median, most. Okay. Now to something a little bit more complicated, a little something new for you. Measures of variation. These are more high-level statistical values and things that are useful. So you can copy that down. These are different values that show us like how dispersed data is, how widespread it might be, and there's a couple different ones. We begin with the mean absolute deviation, also known as the MAD, okay, because it's gonna make you mad. I have to make that joke, I have to, it's obligated, okay? I go to math, teachers, and they're like, you gotta call it MAD. I'm like, okay, because it makes kids mad, and then they laugh. We laugh, we're bad people. Find the mean absolute deviation for this set. So in order to begin to do this, we first have to find the normal mean. Add everything together and find the average. If I do that, the mean is going to be 79.83. Okay, and we can go to 2 digits. That's fine. All right. Now, since we're talking about the distance, right? This is the mean of this set. The average distance of each individual value to the mean. This is where the math gets a little, it's not hard, it's gonna look bad, okay? It's gonna look bad. What I wanna do is I wanna find out how far away this is from that. This is 85, how far is it away from that? So I just wrote it out. Okay, what I did was I took 85, I'll show you what I did over here the first time, and I took away my mean. And I got an answer of 6.17, right? Right? No, it's 5.17. 5.17. Don't listen to me, I don't know what I'm talking about. Okay, that's gonna be my first value. 5.17 plus, how far away is 79.83 from 74? Well, if I take 79 and I subtract that, right, I'm gonna get 5.83. That's how far away it is. How far away is 79.83 from this? It's gonna be plus 8.17. How far away from 80 is it? 0.17. Gotta get other colors involved. It's a terrible yellow, orange. How far away is my mean from this? It's gonna be 12.17. And lastly, how far away is 79.83 from that? 19.83. Okay, important to note, distance is always positive. Notice I never subtracted. It's always just how far something is away. We never talk about distance in terms of negative, okay? I am not negative 10 miles from Birchwood Mall right now. Even if though someone in Birchwood Mall, they'd say, okay, you're 10 miles away from me. I'm still 10 miles away from them. Distance will be positive. So now that I have all my different values and like my distance of them, I need to find the average of this. And I have 1, 2, 3, 4, 5, 6. Oh, it's gonna bug someone that I didn't put purple under there. Gotta fix it. Gotta fix it. It's gonna bug someone. There, you're welcome. You're welcome. All right, now let's sum all of the numerator together, and I already did that. 51.34 divided by 6. I'm gonna get 8.5 something probably, yeah. 8.56. That is my answer. Okay, so let's think, what does this mean, right? The average distance of each value to the mean. So I found the distance of each value. That's my rainbow colors. And then I found the average of those. Okay. Gonna do the same thing here. To figure out what the mean is my first step. The average of those sets of numbers is a nice even 18. Huh, could have started with this one. Nope, gave you the decimal to begin with. That's how good I am. All right, let's figure out how far away is 18 from 14? 4. Plus, how far away is 18 from 18? Well, it's right on it. So put a 0. It's not any kind of far away. Plus, how far? 2. It's 2 away. Plus 1. Oh, I got a lot here. Plus 3, because that's 3 away. Oh, we're gonna have to dig deep into the color well here. I got too many. 14, that's plus 4. Okay, I have to start getting creative. All right, there. Ooh, that's a nice blue. Okay. 15 is 3 away. Ooh, gray. I never use gray. Plus 5. It might look black to you, but trust me, it's gray. That's a weird pink salmon thing. Plus 3. And then one more color. This is the most fascinating part of your day. Mr. K figures out what colors he can make on his board. Okay, those are all of the distances to the mean. Let's add those together and divide by how many data we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, well, that's gonna be easy division at least. If I add together my rainbow of colors, I'm gonna get 26. Divide that by 10, I get 2.6. Okay, so not hard, a little time consuming, but not hard. All right, now we go on to the variance and the standard deviation. The variance is the average squared distance of each value to the mean, and don't be worried about that formula. We're not going to be using it. That's a crazy, crazy formula. That's calculus. If you get to calculus, that's how they derive this. The standard deviation is the square root of the variance. That makes sense. If the symbol, right, for standard deviation is this little O with a tail on it, like that, then the variance is simply that squared. So to find this, I'll just need to square root it. Okay. Standard deviation is the most useful statistical value pretty much across the board. We can talk about the mean of things, and we can talk about the mode of stuff, and even the median gets thrown around a little bit. But that's kind of base level things. The most useful in all of statistics is standard deviation. That's what most relevant data is compared to. And we'll get more into standard deviation in the second half of this, and I'll show you visually how that works. But what do these numbers mean? If I have a lower standard deviation, that means my values are really, really kind of close together. That means maybe I give a test and everyone scores between an 80 and a 90. Okay, everyone's kind of right in the middle there, but I won't have a big standard deviation. If I have a higher standard deviation, that means my scores are really spread out. Kids could have gotten anywhere from 20 to 100. Okay, that would be a higher standard deviation. So let's find the variance and the standard deviation for these sets. All right, we begin. We need to find the mean first. The mean of this set is 92. Now, I'm going to talk about the distance again, the similar thing that we just did. I want to figure out what distance 92 is from 85. Okay, well that's 7 away. All right, so 7. How far away is 92 from 88? 4. From 91? 1. 96? 4. Now, I want to do that one. It's my orange. And 8. Okay. Now, I put these ones in parentheses, and there's a reason, because we are going to square each of these values. Because we're going to find the variance, and the variance is talking about squared stuff. Okay. Now, we need to divide that by 1, 2, 3, 4, 5, the total number of data sets that we have. Okay. Now, I want to express something here as we write this down. Technically, this isn't talking about distance, really. Like in the last one, it was always positive because it was talking about how far away something is. Here, technically speaking, this should be a -7. Like it really should be. Because this is 7 less than that. This should really be a -4. This should be a +1 because it's 1. This is 1 bigger than that. This should be positive and this should be positive. So really, I should have 2 negatives here. But it doesn't matter because when we square stuff, it always ends up turning positive anyway. So technically, yes, this should be negative and that should be negative. But when we do our math, it won't matter if it was positive or negative. Okay, 7 squared, 49. It's gonna bug you, I didn't write that in black. And -7 times -7 is still 49 positive, okay? Plus 4 squared, 16, plus 1 squared, 1, plus 4 squared, 16, and then plus 8 squared, 64. I'm gonna add all that together, and then I'm gonna divide it by 5. That's actually, I can do this in my head. 80 plus 50 is 130, 146. Did I do it? I didn't write it. I didn't write it down. And now I don't trust myself. $146. Is that what I said? I don't know. Okay. Divide that by 5. 29.2. Okay. That is my variance. Okay. And I knew that I was going to do the variance because I was talking about the squared stuff. Now I need to simply take the square root of that to find the standard deviation. The square root of 29.2 is 5.4037, blah, blah, blah. Let's call it 5.4. And that is my standard deviation. Okay? And we'll talk more about what standard deviation means again in the next part of this. We can do the same thing here for the next one. But we also have some calculator tricks that we can do to maybe make this a little bit less involved, even though I don't think that's that bad, but we can still do this. So what we're gonna do is follow these steps here in our calculator, and it will give us a lot of information right at the, really easily. Where's my mouse? It's over here. Professional recording math teacher is always prepared and always knows where his stuff is that he's gonna need to record a lesson. I found it. So I'm gonna go to my calculator. I was watching Bob Ross, okay, and that's pretty on brand. I'm gonna follow the steps on your note packet here. We're gonna hit the stat button, right here, stat. We're gonna hit enter, because I want to edit a list of stats. Now I wanna clear all this out. Looks like I put some stuff in here before. All these numbers shouldn't be here. So if I go up until I'm in L1, it's highlighted, I'll hit clear, and then if I go back down, it's gonna go away. So again, if I have stuff in here and I don't want it in there, I don't wanna go and clear each individual value, that'd take too long. Go up to the top where it says L1 for list 1, hit clear, nothing will happen until you hit down arrow, and then it will reset for you. Now, we're gonna enter our values for the first one. It was 3, enter, 4, enter, 7, enter, 8, enter, 11, 12, whoa, 12, enter, I got another 12, enter, 15, and 19. Enter. Okay, so now all my values are in here from the 19 to the 3. Okay, Now I put in my list, I'm gonna go back to stat, and I'm gonna do something with this list. I'm gonna hit stat, and I'm gonna go over to calculate. Okay, calculate is this middle tab. And I'm gonna hit enter, because I want this first one. I want this first kind of stats. We're gonna choose the list one, hopefully that was already there. We're gonna enter again, a bunch, and it's gonna bring us to this screen, where we got a lot of different things happening. All right, so let's break this down. What are we looking at? This is, I believe, the mean value. So it has a mean of 10.1111. The total of these values is 91. Okay, and the total squared is that, but that doesn't matter for us. What does matter for us, oh yeah, right here, n equals 9, that means I had 9 total values in my list. And I believe if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, yep, that checks. Now, why is this cool for us? Because this value right above the n, see that little O with the tail? That's the standard deviation. Your standard deviation is 4.86, right there. So here, 4.86. I got the standard deviation. That list doesn't give me the variance. It's not a one-stop shop for everything. That'd be cool if it was. But to find the variance, all I have to do is square the standard deviation, right? So if my standard deviation is 4.86, then my variance, my standard deviation squared, which is my variance, will be 4.86 squared. 23.62. Okay, all right, and that's how we can do that. So you have two different methods to do this. I don't know which way will be faster for you, if it's gonna be the calculator way or the longhand way, but you choose, okay, you get to choose. Now, if we're gonna go on and we're gonna do the next one, which I'm gonna not do in the video, but if I wanted to do the calculator way, and I wanna do a new set of data, I'm going to go back to my calculator, I'm gonna hit stat, and then I want to edit those values that I put in. So I'm going to hit enter to edit, and then all this old stuff, scroll up to list 1 here, L1, clear, and then tap down. And now it clears out and it's nice and empty. And I can go in and I can type 40 or 52 and 47, and I can go from there. And I can just repeat that process to get it. Okay, so your choice.